Question 14. We're told to shade the region that satisfy these inequalities. The best is to actually turn the inequalities to equal. So y equals 1. This one is y equals minus x plus 5. What I did there is I subtract x from both sides. And the third one is y equals 2x. So I'm going to sketch these curves. So where y equals 1, this is the curve here. Y equals 1, just go along that line. That's y equals 1. And when y equals 2x, that means when x is 0, y is 0. So that's 1 point for that. When x is 1, y is 2, so that's another point for that. So when x is, we need 2 points to draw a straight line, so we can just draw that straight line actually. So we can just literally draw the straight line. And taking that point from there, I need to draw the straight line in this direction as well. There we go. And this equation is y equals 2x. And the third one is y equals minus x plus 5. So when x is 0, y is 5. So x is 0, y is 5. And when y is 0, x is 5. So now I can just join those lines together. And this curve is y equals minus x plus 5. Now what I need to do is now to follow the inequalities and use those rules. First of all, we need to draw shade when y is greater than 1. So above y equals 1 is greater than 1. We also need to shade where y is less than minus x plus 5. So minus x plus 5, below that we need to shade that. And we also need to shade where y is greater than 2x. So to the right of y equals 2x. So where we need to shade are this region here. So those are the regions where we need to shade. So that's our region. Right, that's what they're asking for. Question 15. Tracy is going to choose a main course and a dessert in a cafe. She can choose from 8 main courses and 7 desserts. Tracy says that to work out the number of different ways of choosing a main course and a dessert, you add 8 and 7. Is Tracy correct? We need to give the reason. Well, in this case, Tracy is not correct, so that will be no, because the combination here is 8 combination 1 for 1 dessert out of 8, and you times that probability by the 7 combination 1. 8 combination 1 is 8, and times that by 7, and that will give us 56. So 56 is the answer we're looking for. The B part, let's look at the B part. 12 teams plays in a competition. Each team plays each other exactly once. We need to work out the total number of games played. Right, so to work out the total number of games, if you're 12 team and you're playing on the others in your team, so one will only play 11 players, 11 teams. So therefore, the total number of games is just adding, just summing 1 plus 2 plus 3 all the way to 11. Basically, that's what we're doing. In order to do that, we can use a formula that says n over 2 into bracket 2a plus n minus 1 of the difference, square bracket, let's use a square bracket, where a is the first term, which is 1, so that's your a, and the difference, d, is the difference between each term, so, and the next one, the adjacent term. So that would be 2 minus 1, which is 1, or 3 minus 2, which is 1. If we plug that in, n is basically 11. So Sn equals 11 over 2 into bracket 2 times 1, which is 2, plus 11 minus 1 times 1, which is now equal to 11 over 2 into bracket 2 times, 2 plus 10, which equals 11 times 12 over 2. 11 times 12 over 2 is 132 divided by 2, and that will give us 66. Question 16. So we need to solve. It says solve. Whenever it says solve, it means make x the subject in this case. So we got x minus 2 to power 2 equals 3. So the best thing to do is to square root both sides. So therefore x minus 2, if I square root a squared, I'll get what's inside the squared. So equals plus or minus root 3, because square root of x minus 2 squared will be equal to plus or minus square root of 3. And square root cancels square root, square root cancels squared, because a square root is a power of a half. So that will be x minus 2 squared times power of a half. And power of a half times 2 is 1. So that will be just x minus 2. So that's the proof of that. Right, so what we now need to do is add 2 to both sides to have x on its own. So x equals 2 plus or minus root 3. So the first value of x will be x equals 2 plus root 3, and that gives us 3.73 in a 3 significant figure. And the second x will be x equals 2 minus root 3, and that gives us 0.276. That will be in 3 significant figures. Right, question 17. We need to find a histogram from the data given. We've got our continuous data, which is the height. And so in order to plot histogram, we need to find the frequency density, so we need frequency density FD. We also need to calculate our class width CW, and obviously we need our frequency, which is the area. Now, so our class width is the difference between the lower class boundary and upper class boundary. The lower class boundary is this vertical here, so that's upper class boundary, and these ones here are the lower class boundary. So for class width, it will be 150 minus 140, so that will be 10. And next is 5. 160 minus 155 is 5. 5 again. 180 minus 165 is 15. So that's our class width. Now we need to calculate the frequency density. And frequency density is frequency over class width. So we go 15 divided by 10. That will be 1.5. And then we've got 5, 30 divided by 5, and that will be 6. And we have 51 divided by 5. That will be 10.2. 36 divided by 5. That will be equal to 7.2. 18 divided by 15. That will be equal to 1.2. Now we need to plot on the y-axis the frequency density. On the x-axis we need to plot the class width, which is the height. So that's centimeter, and here. So now we need to then calibrate this. So I'm going to start with 140 here, 150, 160, 170, 180, and 190. And also I need to work out the height, so I'm going from 1.2 to 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I could do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So each little square is 0.2. So that means 1 divided by 5 is 0.2. Right. So now let's plot the histogram, starting from 1.5 with a class width of 10. So 1.5, so that's 1, and 1.5 is there, so that's 0.5 there, and that's your 10. So that's it. Okay, next one is from 150 to 155, and we are plotting the height of 6. So we want to go 6 up here and halfway down. So we still want to come down. And we want to go up here. So let me just delete all of them and do that again. Make it really nice. Okay, so 1.5. So I'll start from here. Roughly it's 1.5, okay? It's not perfect. And that one. Right, so next one is 6. So let's assume that was 6. And 1.5. So that's good, and we can come down from there. So that's that one. Next one is 155 to 160 is 10.2. So I'm going to start from 10.2 there. So that's 0.2. Better start properly then. So 10.2 there. And go for 5. There we go. And come down. Right. So next one is 7.2 for 5. So I want to go from 160 to 165. Okay, 7.2. So 7.2. Just stop there. There we go. And then come down. Right. And last one is 15 from 165 to 180. So 165 to 180, and I'm going to get 1.2. 1.2. 165 to 180, 1.2. See, there we go. So 165 to 180, and that's 15. And get 1.2. Right. So that is the histogram. And now, B part, we need to work out an estimate for the fraction of the students who had a height between 150 and 170. So what we need is to work out the area. The area gives us the value we need. So number of students. So the number of students is the frequency, and the area of this bar are the frequencies. So we want to work out from 150 to 170. So first of all, 150 to 160, we know those. So we just add those frequencies. The frequency for 150 is, so let's just do this. 150 to 155 is frequency is 30, so we know that's 30. 150 to 155, that's 30. And the frequency for 155 to 160 is 51. So that's 51. The frequency for 165, sorry, 155 to 160 is 51. 160 to 165 is 36. So that would be 36 students. Right, so now we need to work out, we want 170. So we want 170. So 155, 165 to 170. So we need this portion as well. And the area of that portion is going to be, the area of that is 1.22 times that distance here, which is 5. So that's the area, 1.2 times 5. And that gives us the number of students. So 1.2 times 5. Yeah, 1.2 times 5 is 6. So that becomes 6. So that bit here is 6. So when we add them together, we should be able to get the result we need. So we want 30 plus 51 plus 36 plus 6. So that will become 30 plus 51 plus 36 plus 6. That will become 123. Now, so 123 is the total, and we're told to find a fraction of the students who have a height between 150 centimeters and 170. So the fraction is talking about 123 over 150. So that would be what the fraction is. And that is what we called 0.82, which is 82%. So that's the fraction over 150. Question 18. At time t equal to 0 hours, a tank is full of water. Water leaks from the tank. At the end of every hour, there is 2% less water in the tank than at the start of every hour of the hour. The volume of water in liters in the tank at time t hours is given as V0 equals 2000. So, right, we're told to write down the value of K, and Vt plus 1 equals KVT. So K will be equal to Vt plus 1 over Vt. Now, the t plus 1 and t are subscript, so that's important. So at t equal to 0, you're going to get V0 plus 1. That means in 1 hour, and then V0. Now, in 1 hour, the water is lessened by 2%. 2% is 2 over 100, which is 0.02. So so we're going to have 2000 times 0.98, because instead of timesing it by 1, so it's less by 2%. So you take away 0.02 from 1, so that gives us 0.98. We divide it by V0. So V0 is 2000. 2000 cancel 2000, and we're gonna get 0.98 for K. So K is 0.98.